Hello, ladies and gentlemen. I'm Mr. White, and this is lesson 11-2. In the previous lesson that Mr. Fuller had done with you, you learned to simplify rational expressions. And remember, rational expressions are ratios or fractions. Okay, in this lesson, we're going to now multiply more rational expressions together and then simplify those resulting products. Quick extension from example 1 and 2. Remember, based on what Mr. Fuller had said, there's two types of problems that we are looking at. Like example 1 has no addition or subtraction symbols. Okay? And then there's example 2 where we have addition or subtraction, where we actually have to use either Xbox or factor rules. We need to find each product, simplifying the resulting rational expressions completely. What we would like to do is to break down our rational expressions to the simplest form, or get all the common factors that we can possibly get. So example 1, what we want to do is we have two rational expressions that we are multiplying together. So we need to break down each one to its basic factors and then see if we can cancel anything that's on top that's also on bottom. So for instance, and we're going to try and put the numbers first and then the variables after the numbers. 7 can only be broken down into 7. 15 we know is 3 times 5, so we have 3 times 5. And then we have two a's on top, so a times a. Okay? Because it's multiplication, we can generally multiply the numerators and then multiply the denominators and then look to cancel. So we'll draw those commonly over a line, and then 5 can only be broken down into 5. And then we have 14, which is 2 times 7. Okay? And we have 1a. Okay? So if we look at both numerator and denominator, now we're going to look for like terms. And we can see that there is a 7 on top and bottom. There is no 3, but there's a 5 also on top and bottom. And then we can cancel 1a on top and 1a on bottom. So glancing over, what do we have left? On the numerator, we have a 3 and an 8, which gives us 3a divided by 2. So there is our answer, 3a over 2. Number 3, doing the same thing, we're going to start with the 10r cubed. Okay, 10 can be broken down into 2 times 5. The 42 is 6 times 7, but 6 can be broken down into 2 times 3, and then we have the 7. And then we'll just put the r's first. We have 3 r's, and we have x times x. Because of multiplication, we're combining them all on top. Okay, we'll draw them all over one line. And we have 6. 6 is 2 times 3, and 35 is 7 times 5. Okay? And then we look at the variables. We have 3 x's and 3 r's. So we'll keep the r's first, and then we have the 3 x's. Then again, we look to what is common on top, or the numerator, with the bottom denominator. If we start on the numerator, we have a 2, we can cancel a 2. We have a 5 on top, and we also have a 5 on bottom. We have another 2, but there is no more 2's. We have a 3 on top and a 3 on bottom. And then we have a 7 on top and a 7 on bottom. We have 3 r's on top that can cancel with r cubed on bottom. And we have 2 x's that can cancel with only 2 x's on bottom. So if we glance over and look at what's not crossed off, okay, we have left now with 2 on top and an x on bottom. So our answer is 2 over x. All right, number 5. 64 y squared over 5y times 5y over 8y. We can break down 64 into 8 times 8. 8 times 8 is 2 times 2, which is 4, times another 2. And then we have that 2 times 2 times 2 again. So there's 8 times 8, and then we still have a 5. Okay? And then with the 64, we have 2 y's, and with the 5, we have another y. So we had 3 y's total on top. Okay? And then now we're going to break down the 5. So we have a 5, and then we have an 8, which is 2 times 2 times 2. And then we have 2 y's on bottom. So now, cancel out whatever's on top. If it could go into what's on bottom, we have 1, 2, 3, 4, 5, 6 2's on top, but we only have 3 that can cancel. So if we cancel those 3, we have a 5 and a 5 we can cancel. And the most amount of y's that we can cancel, there's 3 on top, but there's only 2 on bottom that we can go. So if we put everything together, nothing left to cancel. 2 times 2 times 2 is 8, with a y left on top, and there is just a 1 left on bottom. So our answer is 8y. All right, we're going to have you do the evens now. Go ahead, hit pause. Do 2, 4, and 6. Check back with us in a few minutes. Go. All right, welcome back. If you noticed, you should have gotten 3m squared for 2. For number 4, you should have gotten 4b squared r over 3a. And for 6, you should have gotten 5ac. Okay. If you're stuck or not sure, please ask a student when you get back to class. Be sure to ask for help from your teacher. Next page. All right, for this side, we are going to do the evens, starting with 8. If you notice, again, just like 11-1 with Mr. Fuller, we are now looking at the added symbols, addition or subtraction. So with addition, subtraction, now we are going to possibly have to use Xbox for factoring or factor out common factors. And again, then use our rational expression canceling or simplify whatever's on top, can cancel with on bottom. So for 8, remember, because we are multiplying 2 rational expressions, we can really combine, where this time sign is, we really can multiply the numerators together and then multiply the denominators together and then look to see that we can cancel. So if we start with the 5a plus 10 over the 10b squared, because of this addition symbol, okay, we're going to have to look at what common factor can we take out of the 5a and the 10, because those are joined together. So if we notice, and it is not a square, so we're not going to use Xbox, I can take out, or you can take out, a 5. So if we take out a 5, then what's left is a plus 2. And we're using the grouping symbol symbolizing that the a plus 2 has to be joined together. If we look at the 10b squared now, we know that 10 is 2 times 5, and then we have 2 b's that are associated. Because we are multiplying 2 rational expressions, let's just extend division sign out. Okay, and then we go back to the top. 4b cubed is times 2 times 2, and then we have 3b's. And then now we have the quadratic a squared plus 11a plus 18. If we use our Xbox, and because, like Mr. Fuller reminded us, because of the 1, when we multiply, we are really looking at what times what equals 18, but can add to get 11. Okay? And hopefully you're thinking of the numbers 9 and 2. Need more help? Please use the box method. Okay? But we should be able to factor out and get a plus 9 times a plus 2. Now that we have everything factored as completely as possible, now what we want to look at is go down the line and see, is there anything that's on top that we can cancel with on bottom? So if we start with the 5, we have a 5 here, and then we can cancel with a 5 on the bottom. Okay. If we go across the top, there is a 2 that we can cancel with a 2. There's another 2, but if you notice, there is an a plus 2, but because of the plus sign in the parentheses, if we were going to cancel the 2 inside, we would also have to cancel that a plus 2. So the 2 is just by itself, so we cannot cancel with the a plus 2. We have a b that I can cancel with, 1b on the bottom. We have another b that I can cancel, so we got rid of 2 b's. If you notice, now going back, we have an a plus 2, so we could take that whole a plus 2 and cancel with the a plus 2 on bottom. If we look, it doesn't look like there's anything else. So if we go across the top, we are left with still a 2b and then an a plus 9. The a cannot cancel, the a plus 9 cannot cancel, the 9 cannot cancel. So we are left with that rational expression. Okay, number 10. We have x squared minus y squared. It is a binomial. If we can remember, it is missing a term. And the term that is missing is that middle b term. So hopefully we can remember that this is really plus or minus 0 xy, because we have two variables, and then minus y squared, and then we still have the 12 times, we still have the 36, and we have that x plus y. So we want to start with this factoring with the x squared with the quadratic. We can use xbox. We have a 1 times the 1, or the negative 1. So we have a negative 1 on top, and we have 0 on bottom. So what times what equals negative 1, but adds to get 0? And the only answer is negative 1 and 1. Okay? Now be careful, because we do have two y squares. If we put into our box, okay, first term will be x squared. Now this is negative 1, but we have two variables, so we are using an x and a y. Okay? And we then have a 1 y xy, and then we still have our negative y squared. So when we factor out, starting with the top boxes and going left, we have an x squared. We can pull out just an x. Okay, on the bottom, the only thing we can pull out is a y. And then going up, we can pull out an x again, but this time we can pull out a negative y. So that top expression can factor to x minus y times x plus y. 12 is 4 times 3, or 2 times 2 times 3. And 36 is 6 times 6, or 2 times 3 times 2 times 3. And then there's nothing we can do with the x plus y, so we leave it as x plus y. And the reason why I'm putting parentheses is if I cancel the x or the y, I need to cancel the whole thing, the x plus y. So if we go back, we can notice that this x plus y on the bottom can cancel with the x plus y that's on top. We have two 2's that can cancel with the two 2's on bottom, and we have only 1 3 that can cancel there. So what's left on top? We do have a 3 times the quantity x minus y all over nothing, or 1. Okay. So our answer is, and we'll leave it in factored form, 3 times the quantity x minus y. All right, number 12. The first thing we want to look at is, what do we have? We have 4x divided by 9x squared minus 25 times 3x plus 5. One thing we can do is, we have one fraction times a quantity. Let's put this over 1 so that we have two rational expressions, or two fractions. Okay, and then now we want to see if we can factor. Remember, we're drawing just one line because we can take the numerators and combine them. 4x is 2 times x. And then is there any comment, because it's not a squared, is there anything that we can take out with the 3x plus 5? And the answer is no. So we have just, keep it in parentheses, 3x plus 5. Now we want to concentrate on the 9x squared minus 25. Remember, it is a quadratic binomial, so it is missing that b term. So this is really 9x squared plus 0x minus 25. 9 times negative 25 is going to give us negative 225. And then we have a 0 in the middle. So we have to think, what times what equals negative 225, but adds to get 0. Hopefully our squares are doing pretty good, because it's 15 times negative 15. Now with the big number in the 9, so let's use our box method. We can put the 9x squared in the top left. We'll put the minus 25 in the bottom right. Okay, and then we have 15x and negative 15x. By factoring out, starting from the bottom top on the left, we can pull out a 3x. And because this first one is negative, we can take out a minus 5. And if we go from the right to the left on the top, we can pull out a 3x again, but this time only a positive 5. So our factors from the 9x squared minus 25, which is also called a perfect square binomial, or the difference of two perfect squares, becomes 3x minus 5 and 3x plus 5. And then we have just that 1, or we don't need to write the 1. So now that everything is factored completely, we look to cancel whatever's on top and bottom. Okay. One thing we do notice, there is this binomial 3x plus 5 that we can cancel with the binomial on the bottom, 3x plus 5. And there seems to be nothing else. We cannot cancel a 2 with the 3x minus 5. We don't even have a 3x minus 5 on top. So we can combine the top and give us 4x over 3x minus 5. Okay? Be extra careful. Remember, just because we have an x on top and an x on bottom, in order to get those canceled, you would have to cancel the whole 3x minus 5. So we do not cancel, especially because of this minus sign. So we leave it as 4x divided by 3x minus 5. All right, one more. 14. Okay, notice we have a quadratic trinomial divided by a quadratic binomial. We have another quadratic trinomial divided by a quadratic trinomial again. If you notice these a terms, they are all 1, so we can do the first part of our x box, and then if you need the box, go ahead and perform the box. So if we start with the first one, I need to factor. There is no greatest common factor we can take out, but we know that what times what equals negative 6, but adds to get negative 1. And that answer is negative 3 and positive 2. So we can factor the top left to c minus 3, put parentheses to group those together, and then c plus 2. Draw a line to symbolize the whole numerator. If we do the other numerator, we have what times what equals 12, but adds to get 7. And hopefully you're thinking 3 and 4. So we can factor c squared plus 7c plus 12 to c plus 3 and c plus 4. So all the numerators are factored. We have a binomial. Remember, this binomial is c squared plus 0c minus 9. So what times what equals negative 9, but adds to get 0. And that's 3 and negative 3. So we can factor c squared minus 9 to c minus 3 and c plus 3. Okay. And then the last one that we have, what times what equals 4, but adds to get 4, and that's 2 and 2. So we can factor c squared plus 4c plus 4 to c plus 2 and c plus 2. Now with canceling, we have all binomials, so we have to cancel the whole binomial within the parentheses. We have a c minus 3 that can cancel with the c minus 3. We have a c plus 2 that can cancel with the c plus 2. And we have a c plus 3 that can cancel with the c plus 3. So the only thing left that we have is c plus 4 on top divided by c plus 2. I know what you're thinking. Okay. We have c's and we have a 4 and a 2 that have common terms. Okay. Because of this symbol or the plus symbols that are in the middle, you have to group these two together, so we cannot cancel both of those at all. So we must leave it. So our answer is c plus 4 over c plus 2. All right, go ahead, hit pause. You're going to do the left side, 7, 9, 11, and 13. When you are finished, please restart the video and check your answers. Go. All right, welcome back. Number 7, you should have gotten 2m divided by 3 times the quantity m plus 5. Number 9 should have had just 2. 11 should have been just 36. And number 13 should have been 4 divided by 5 times the quantity y plus 5. As always, remember, if you have any questions, please see your teacher as soon as possible. If not, have a wonderful day, afternoon, or morning. And always do your best, forget the rest. Bye for now.